We want to simplify this expression, so let's see what we can do. This argument, what you take the log of is called an argument. So this argument here looks to me like a product, right? We've got 10 times e to the 3t. So this is a product, so I'm going to use the property of logarithms that says I can break a product into the sum of two logs. So I'm going to write this as the natural log of 10 plus the natural log of e to the 3t. Now the natural log of 10, don't think there's much we can do with that, but look at this. Now this is something that we've seen before, and we're going to see it often. When you have something like this, this is really what? The log base e of e to the 3t. So what you're looking at here is an exponent. And exponents go on bases. So what exponent are you going to put on that base, e? So you're thinking, okay, what exponent would I put on there to get e to the 3t? Right, so that has got to be the 3t. And what has happened is that we started with 3t. All right, I'll write this down. We start with 3t, we exponentiate it, then we natural log it, and we're back to 3t, right? Because the exponential function and the logarithmic function are inverses of each other when they have the same base. So in general, we want to pay attention to this here. If you have something that looks like this now, say the natural log of e to the x, whatever x is, it could be 3t in this case. This is just equal to x. So for us, back here, we have the natural log of 10 plus, then I see this, right? I know what this is. Now this is just 3t, so we'll get it in there somehow. So I get the natural log of 10 plus 3t. Now on to 61. Now look at 61. Doesn't it sure look like 59, except instead of a 10, we have an a, and instead of a 3t, we have a negative 2t. So I'm still going to break this apart step by step here. This will be the natural log of a plus, because I've got a multiplication here, right? That's a multiplication. The natural log of e to the negative 2t. Natural log of a, can't do much with that. But this one over here, what are you going to get? The bases match. So you just get the exponent, which is minus 2t. 63, we've got the common log now of, now look inside here. This is a product. You see in a product right here? Right, it's 100 times that. So I've got the log of a product, so I'm going to write it as the sum of the logs. So I'm going to write this as the log of 100 plus the log of 1.01 to the 3t. Now what's this log of 100? Well, the base is 10, right? So the base is 10. So this is an exponent. What exponent do you put on 10 to get to 100? It's 2. Right? So this is 2 plus. Now I don't think there's anything we can do here, right? This base is different than this base. So we're just going to have to write it as it is. So log of 1.01 to the 3t. Well, now that I look at it, I can probably go one step further, right? I've got the logarithm of something to a power. I can bring that power down in front, so I think I'll go ahead and do that. So it'll be 2 plus 3t times the log of 1.01. That's probably the best I can do with that one.